Alright, so let's start adding some electricity. I know I already have some tutorials online where I already used electricity, but I'm gonna do it a little bit different in this tutorial. Just with a little bit more facts to sort of make it a little bit more interesting. And probably also because it kind of fits the course, because the course is a little bit more facts heavy, a little bit more advanced stuff. So I figured might as well do it. It's still going to be rather simple. And electricity is always just quite fun to do. It just looks super cool. I mean, I did these boxes and I figured I need electricity now to make it look even cooler. So anyway, yeah, we already, we have the Orbi things. Now let's do the electricity stuff. So yeah, let's just make a node, I guess, and let's call it electricity. All right, let's go in there. And let's just merge our boxes in there. Let's hide our other stuff into this object. And we want to isolate our red little piece here. Delete non-selected, because we will also need that later, because we're going to focus the electricity sort of. Yeah, I'm not sure how clear it is here, but the electricity is sort of focused around that one thing. And like there's still electricity here, and then it sort of all sparks towards that point. Even though it's not necessarily always that clear, but that's what it does. So main, and then do the other one. Let's do non-selected. Oh, and by the way, don't make the mistake that I did of rerunning your sim and not having the centerpiece be the same piece, because then you're gonna have to re-render because we're blasting it non-procedurally. You could also blast it, I guess, procedurally if you wanted to. I mean, we probably have an attribute here that we could use for that. Do we have the distance attribute? Dist. I mean, I guess if you want to do this procedurally, you could say that if dist equals 1, remove point. Does that work? Does not equal 1. Right. And then do the other one. So I guess if you do it like this, at least you can be sure. So that's the distance attribute, right? So we had these attributes. So these are 0 and then this is 1. So I guess if we're going to do it like that, maybe this is going to be a better way. So blast. And so let's call this blast. Right. So just so we know that you're not gonna run into the same issue, because if we were to do this manually, like if I were to blast this, non-selected, and like let's say if we change the sim and then this isolated piece that we blasted here is going to change, there might be an issue here where you can see where our centerpiece is no longer selected. But if we do it this way, there's never a problem, because this one will always be distance equals does not equal 1, or distance equal 1. Yeah. All right, so let's just unpack these things so we can sort of scatter some points on here. So we get, yeah, we could just get these points that are sort of jumping around, but in our case now this is fine. I mean, we could also get away from doing that, but in this case, I guess it doesn't matter if they jump around, because with electricity that looks kind of cool. All right, so what we also want to do, we want to do an attribute VOP here, and we'll just add some movement to these things. So with noises, I always just like to use VOPs, just easier. Because in Vex you have to manually create all these channels, which I don't like. Let's put just put the time in the offset, and let's add a multiply there. So if we do that, let's put a time shift, and it's essentially what it's going to do is it's going to sort of move the noise around based on some time. Did we promote this? Right, let's put a So now we have a sort of a control here. So you can see now they're going to sort of move around. Of course, we don't want them to move off the surface, so let's just ray them to the original thing. So let's ray them to the original surface. Let me just demo this by putting them to the time shift first, because then you can sort of see what's going on. All right. And let's put it to minimum distance. All right, now you can see them sort of move, so they get projected back on the surface. So now we have them, yeah, it's moving on the surface. So now let's just disable this time shift. So now they sort of, yeah, they move, and it's a little bit slow without the time shift. Maybe we can just make something that it's going to be faster. That might be nice, just saves on the cooking time. All right, so what we're going to do is we're going to transform these things by the position of the original thing here. There's multiple ways to, of course, do this. We're not going to, in this case, use this transform pieces thing, which you might think. We're not going to use point deform either. Probably the fastest way to do this, and might also be an interesting way to do this, is with a little bit of vex. So we're going to put a thing in here. So we're going to make our own sort of deformation thing. So in our first input, let's put in the geometry that we want to deform. In the second input, let's put in the rest position. So that's essentially going to be the time frozen position. In the third input, let's do the animated one. All right. So let's first just define some things here. So let's call one prim. So let's go for a primitive number and vector UV. All right. So might ask, okay, what are we going to do with this? Well, what we're going to do is we're going to call a function called XYZ distance. So if we just open up our help file, finds the distance from the origin, so from the current position, to the closest point on the geometry. And then it's going to extract some stuff from that. Essentially what we're going to extract is we're going to extract the primitive number and the primitive UV. So every, so you might ask primitive UV, well, we didn't do any UVs. Well, essentially every sort of polygon has its own intrinsic UV positions. So let's say if I have this polygon here, it has its own UV coordinates. So like, let's say this would be 0, 0, 0 coordinates. This would be 0, 1, 0, or whatever. Anyway, they have their own intrinsic coordinates, and we can extract that, and then we can sort of compare that to where it is. Like we do that on the sort of the frozen position, and we're going to apply it on this geometry here, and then deform it by the animated stuff. It's going to become clearer in a little bit. Anyway, what we're going to do is let's just grab our help file with us. So it's just what do we want to look for? We want the first input, because that's for the frozen input. What's going to be the origin position? What's going to be our position, right? We're going to sample from our position. And then we're gonna put this stuff into the prim thing that we created, and we're gonna put it into the UV thing. And if they have this asterisk here, I'm not sure if it's called an asterisk, but in Dutch we call it an N sign. Anyway, these things can be piped into another function, and that function is called, I think they even mentioned it here, it's called a prim UV. The function overrides UV card closest point, closest surface. So if we use that function, what we could say, for example, v at p, so we want to set our current position to, let's type prim UV, and then we're going to set it to the position of the second input, so the animate position. We want to set our position, so p. Let's, by the way, open this in the help file. So geometry, attribute name, and then again, it's asking here for these things. So the primitive number, so it's going to look for every primitive, so it's going to look for every polygon that it extracted here. And then it's going to use it in this prim UV function to set the position. So it's going to extract that, and it's going to extract the prim number with the corresponding coordinates. So we can just call, say, prim, and we can say UV, and we can press enter. I'm gonna look at this thing. You can see now we have our animated points, and it's a lot faster than what we had before. Mind you that this only works on like a 2D space. So if we had, for example, points scattered here in a 3D space, we can show you. Because it's essentially what it's doing is kind of like with the ray swap, right? Just similar. It's just projecting them on a on the surface of the geometry. So if we were to do this, so I have points in a 3D space here. If we were to then do it like this, you can see they are being projected onto the box. So it's not, you can see they're no longer in 3D space. So, but for this case, this is completely fine. Right, anyway, now we have animated points that are going on our little boxy things here. Beautiful. All right, now let's do some electricity stuff. All right, so actually we recorded this a couple of times, this part, because there's actually like 1001 ways to do the next step. Like literally you could do this anyway. I'm gonna show you 2 ways. So just a very simple way, and then another way to just do it in Vex. Because what we're gonna do is we're gonna have this box here, and we're gonna scatter some points on this. Scatter. And let's turn off relax iterations. The amount of point here will roughly control like the maximum amount of electricity arcs that we're gonna have. So what we're gonna do is from this thing, we're gonna sort of look around and we're gonna draw lines to near points here. So, and you can actually do this super simple in SOPs. And we can also do it in Vex. And I figured it would be cool to show you both ways. Because in Vex, we're going to deal a little bit with some geometry creation inside of Vex itself, which I figured would be more interesting than just doing this with SOP. So I'm just going to first go over this in Vex, and then we're going to do sort of the same thing just with SOP nodes, which is probably what I would do if I do this, which I generally is the way that I would do it, but figured it would just be more interesting with a little bit of Vex. So yeah, with it out of the way, let's just set that up. We actually want to just make a wrangle here, and we want to first put in the scattered points from our box here, and then the other scattered points on the other side. So let's highlight that. All right, so a couple of things that we wanna do. First, let's load in some points. So vector p1. So this is similar to what we did also with the interaction stuff. Let's say point, first input, position at pt_num. So we're gonna load just the position of the. And again, if we were to type at p, that would sort of be the same. And then we're gonna copy and paste this. And then use P2. All right, and so now this is gonna, and then we're gonna do a thing here. So this is gonna essentially, oh, by the way, let's put it to 1. It's gonna load the positions which correspond sort of with the same point number. So if I have like 0.1 here, it's gonna look for 0.1 around here, and then it's gonna do its thing with that. Right, so let's calculate our distance thing. So it's a similar thing that we had before. So float dist equals distance, and then between P1 and P2. And then we wanna sort of add some lines to this. So let's say if dist is below, let's make a channel float, and let's say max dist. And let's open and close brackets, Control Enter, see if this works. Let's do max dist actually. Let's create this as a slider. Then we wanna do a bunch of stuff. So first, what do we want to do? Well, so we looked up for the position of the points around this point, right? We're drawing an imaginary circle around it. And we want to be able to draw a line from our current point to that point. But in order to draw the line, you actually need, you need that point on your current input stream, right? Because right now we have a bunch of points here. And we want to be able to draw a line, and we cannot draw a line to points that are not there, that are only on a different stream. So let's type int for integer. Let's call it my pt equals. And let's type add point. So add point will add a point. We're going to do it on the first input stream, and we're going to add it at the position of p2. This again is where we did those things. So if I now middle mouse, nothing will have happened yet, probably because we don't have any radius. But if I were to increase this big enough, you can see we can start getting more points in there. So if I just template this, and you can see we get points here on our thing. So it's gonna like check for distance. And the point here that it's grabbing is the point that corresponds with the index. So if I have 0.1 over here, it's gonna load it in. So the maximum amount of points we're gonna find here should be the amount of points that we have over here. So if I were to add like 10 thing in here, then we get maximum of 20 over there. So kind of hope that makes sense. We probably want to sort of maybe randomize that a little bit, because maybe we don't want to sort of do it to the like exact point. We want maybe some sort of a seed. So let's implement a little bit of a seed over there. So let's just, I guess, write some code above this. So let's first say float r equals random. We're going to say random based on the point number. And we want to grab another thing. We want to say integer n, or you could call this whatever you want. We want to say n points. And we want to grab it from the first input stream. So n points will grab the amount of points that are on the first input stream. So that will be, in this case, 1000 points. So this n will be 1000. All right, so then what we can do is we can say r equals fit 0, 1. And we're going to fit r between 0 and n. So now r will be between 0 and 1000, but it's float, so let's round to integer. So something like that. And then we can, instead of looking for a point number here, we could look for r, and you can see already like our points that our points changed. So now it's doing it with more random points, and it's complaining because we didn't declare this to be an actual integer. So I guess let's declare this to be an actual integer. And why is it still we should probably maybe actually make an integer, so integer k or something equals int r, and then say k or something. All right, so then it will stop complaining. But now that we have this thing here, you can also do some other functions here, right? We could say that plus channel I seed, so we could add a seed there. And then if we move this, you can see it's sort of like the points that it's grabbing is random. Of course, then we still have this control here over how far are you gonna look. All right, so now another thing that we need to do is we need to draw some lines between these points and our original points. So we can just do with that is say add prim, pretty simple. Let's open the help file so we can sort of see what we're doing. So let's put a 0 here and then say polyline, and then say add ptnum, and so between the current point number and my pt. Let's have a look, and you can see now we get a whole bunch of lines. It's we now play, you can see burr, 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 burr. And of course we have this sort of control over like how far do we want sort of this thing to be. And of course over here we have sort of control over like how many points do we even scatter on that. So with the seed we can sort of change like the seed, like the look a little bit over. And of course you can add like functions over there, like plus, like to do it every frame or whatever. Or you could do that over here like we did before. So $t times 10. So then it will do it. So again, like now we just have this invex, and you can do all the things you want. I guess let's just keep it as a static seed for now. So yeah, and then we can use these lines to make some electricity arcs. Right, so this is the sort of a Vex way to do it. There's multiple ways actually to do this in Vex. Like you could do this literally 1001 ways. So I'm also going to show you a way to do it in SOPs. So if you were to do this just in SOPs, what we could do is just do an triangle. And let's just create a, say I at ID equals ptnum. So just to write out an ID, we're going to do that the same over there. And we're going to merge it together. So now we have IDs on these things. And then we can say add. Then we're going to go polygons by group, by attribute, and type ID. And you can see we also got some lines where we get super long lines. So then what you could do is we'd say, all right, now let's measure these lines. So we'd say the perimeter. So it's going to here the length. So let's do an attribute triangle. Let's go run it over primitives and then say that let's maybe just call this len here. It's probably easier to just type out. It's if len is greater than general float max len. I'm going to say remove 0.0 and add ptnum. Right. If at len. All right. And let's do. All right. So essentially, we will have something similar now, right, to what we had here in just one wrangle. Of course, now here the seed is a little bit different here. So I guess if we put the I mean, we are like, it looks a little bit like the lines that are connected is a little bit different. But essentially, this is the same. The only difference here is that what we're doing here is we're literally just connecting all of the lines. And then after that, we're measuring them and we're removing them. So, and then over here, we're doing it all in one wrangle. So we're not even creating the geometry unless it's specified that it adheres to this condition that we established. So I guess if you have like a ton of points, this would probably theoretically be a little bit faster. But realistically, with this setup, it's not really gonna make that big of a difference. Like honestly, like most of the times, if I just do electricity, I would probably just do it like this. But I guess this is a little bit cleaner. And again, if you have it in Vex like this, of course, you have a lot more flexibility to like do stuff to your heart's content. But I figured just would be cool to sort of go over this stuff, like in case you didn't know how we can do sort of geometry creation inside of Vex. So this is a simple example of how to do some geometry creation. All right, so now let's actually make some electricity arcs from these things, because right now, of course, they're not really looking that interesting. Because right now they're just still lines. So let's make some electricity arcs from them. So what we need to do is we have these curves here. Let's resample them. And those of you that have watched Houdini 101 already know all about this. Let's maybe do 0.8. Let's or 0.5. Let's enable here curve view attribute. So curve U attribute will create a 0 to 1 attribute across our curve, and we can use that to sort of do some stuff. So we can use an attribute swap here. And let's say we can do turbulent noise. Boop. All right, let's put an add. And then we want to make it a 3D noise. So we want to add it to the position. You can see we get this wavy position, but we want to promote these parameters. Alright, so like that. And let's pop out our amplitude, and then let's do a ramp parameter. And we wanna, so we first want to bind something in. Maybe let's do this full screen, so it's a little bit easier to see. So we want to bind in an attribute, and we want to bind in our curve U. Let's ramp that with our ramp parameter, spline ramp, and then let's multiply our little amplitude here. So, all right. So if we now go out of this, let's go into our electricity on the right here. So now I can sort of do this like only on the, for example, on the center, or only on the edges or whatever, because we do want them to sort of stick right to the boxes themselves. Because if we don't do that, then so if let me just template these boxes, because we do want them to sort of stick to these boxes, because it's electricity, so it's gonna look for a close point, right? That's what electricity does. So let's also, what I like to do is like you can put some offsets. You can put time in the offset, and of course this is a vector, and so this will put every so this is a float, and it will put every component of the float in the vector, so we'll just offset each channel the same. Let's put a multiply between there, and let's promote, just call this speed, and speed. And let's just, so with this we can control the speed. So if we, and by the way, let's time shift this entire thing maybe, so it's just a little bit easier to just work with if we don't really, if we're not just looking at our entire thing, right? So now we can really like increase the amplitude here, and let's do, this looks like it's still 1D noise, that's 3D noise. Let's promote the type. And I literally always forget, even after all these years, what type I like best. So yeah, something like this is probably okay. So let's increase the speed, so you're gonna get like these sort of wavy archy stuff. There's also another noise which is quite nice, which is the anti-alias flow noise. So that's also, so you could also try that. That has sort of a loopable flowy motion. You could throw that in, make it 3D. So let's try that instead. You could just throw that in, put this in the amplitude, pop out frequency, and we don't need to pop out the offset particularly. Let's pop out roughness. And I'm trying to use my tablet more in Houdini, because I have like a little bit of a carpal tunnel, so I'm just getting used to it, the tablet inside of Houdini. So I'm now switch to the mouse again. Anyway, so let's put the roughness in, and I guess we could promote flow and flow. All right, so with that thing, let's let's increase the flow a little bit. So let's put the time in the flow. So that's this thing. Let's put that in flow. And okay, you can see we get sort of a nice flowy motion. So I guess like the look that you want depends on, well, on what you like. And of course this would need to be a lot faster, because it's but you can see this sort of loops. So I'd probably just use the turbulent one. These are the type of stuff you can also easily acetize. For example, like this is something that I've acetized, for example. So I can just, like here I have a just an HDA. So like if you have tasks like this that you do quite a lot, probably you like just assetize it. So you can see I'm doing the whole resample thing, like computing a custom curve view here, doing all of this. So this would, like, I could just plug this into a curve. And why is not working in this case? Did I mess this up? Curve view. Oh, that's weird. The review. All right. Anyway. Oh, but yeah, because it's not resampled yet. So anyway, so this is stuff that you can easily also just assetize yourself. Like for example, I have it, so I can easily switch between flow noise and turbulent noise. I'll include this in the downloads. So I'm just going to use this to do the thing probably. So I guess we could change the speed a little bit. So this looks kind of nice. So you have to sort of just play with the way you like it. And what you generally probably want to do is like have some bigger arcs. So this would be like bigger arcs, big arcs, maybe a little bit slower for those. And then we could resample them again. And then do get like a lot of points on those, and then like do another one. And really increase the frequency and like decrease the amplitude, maybe increase the roughness and increase the speed. So that's what would yield you like this is a really small scale turbulence. So let's turn off the time shift there. So we probably want to randomize this a little bit. So let's add time times 10. Rinse. And you could also just type this in the vector angle itself. But all right, so now this would sort of be a little bit more random. Right, so that's looking pretty dope. And of course we have the you can change the stuff there. We would probably want to keyframe also the scatter points, like maybe we want like a lot here, and then so it's gonna sort of decrease, and then it's gonna fall like on the ground, and it's only gonna have like a couple. And then we're gonna let's template some of the stuff here. And we're gonna really like increase it again. So I guess like just keyframing a little bit, but then you get like super cool. Electricity always looks dope, and it's pretty easy to make, and it just adds a lot to stuff like this. We want another arc. Let's just move this. I'll just leave this in the file here, so you can also have a look at that. So we want to do some more arc. Oh, by the way, what we want to do also, I guess, is do the animation here on these points. So like on our box points, right? We want those to move, and then I guess we want to array those as well. So we get points moving across that. I guess we could decrease the amplitude a little bit there. So that that probably makes it a little bit more interesting. And we probably want some like an additional arcs, like arcs that are just on our single box. So let's do some more scatter. So let's let's just copy this thing. Let's put a seed in here. So let's say rinse time times 12. And on the other one, let's do that. Copy and paste. Plus a random number, so plus 69 or something, or do like plus 420, whatever. Right, so we have these things. I guess we could just maybe use this setup for this for now. So let's copy this stuff. And so let's move that in. And we get a bunch of lines here. And let's resample those. So we get some points here. Now what we want to do is we want to array this. And array it to our original box. Put it to minimum distance. So we get like these lines across our box. Let's do project rays maybe. Give it to project rays. Let's give it a whole bunch more points now. Let's sort of bulge these outward a little bit. So let's attribute transfer some stuff. So let's transfer the normals from our original geometry here. All right, so let's put a facet here. Let's create post compute normals. So now we get some normals here. Should probably need more. So let's put subdivide here. Is this gonna be slow? Nah, this is pretty fast. Yeah, so we want to transfer these normals to our lines. So now we get those things. Let's, by the way, enable our curve view on our thing here. Now what we want to do is bulge this out a little bit, like some arcs. So let's say that we want to do some, I'm gonna go back to the Wacom for now. So like this. All right, so I'm gonna say that we want to add, so at P, let's say plus equals at N. So we just do that, it bulges like way the fuck out. We want to do this times a certain value. So let's say float, I guess, offset. And let's make a, let's say, so channel ramp. And what do you want? My ramp. Yeah, or offset or something. And we want to do it based on the at curve view. All right, oh, curve view. And you want to use this times the offset. So now we get a, we have a control where we can sort of offset it, but this is of course way too extreme. So let's do another, let's say multi. So let's create a, just a slider. Here you can sort of multiply the thing. So I guess what we could do with this is select all the points here and put them to Bezier. So you can see now we get sort of nice bulging arcs here. And then once we have those bulging arcs, we could just do our other thing here with the whole creating electricity. So I guess let's do something like this. And the second one should be pretty low as well. We could probably get away with just doing one over here, but this is way too extreme. Probably want way less points on this as well, because I think this is probably just way too much. Something like that, and let's do, yeah, let you really tiny detail. So yeah, something like that's probably pretty cool. Yeah, so we have that stuff. Could line that out, I guess. So could merge this whole thing in. So when you have, we have our stuff here, and we actually want to mesh this. So you can actually you can render this multiple ways, but so okay. So I'm gonna actually mesh this, and the reason for that being is because I want to use it as a geolite, and unless I'm wrong, a geolite needs an actual mesh. So that's why I'm going to put this into a as a polywire. And I mean, it's not that many things, but like if you were to do this otherwise, you could also just render this stuff as strands on Redshift, and then strands render as objects, and then cylinder. So you could also do that at render time, but we're gonna make it into a mesh because we want to use it as a geolite. Yeah, it could be that I'm now wrong and that it will also, that the geolite will also just take up these strands. But from the top of my mind, it doesn't. But feel free to try it out or correct me if I'm wrong. So I actually tested it out and I was right, it didn't work. So let's do an attribute swap here. Let's first, what I'm gonna do is let's polywire. So what I'm gonna do is I'm gonna just polywire this whole thing. So let's go to a certain frame. Alright, so let's just go to one where there's like a whole bunch of electricity. I guess like one like this. So we're gonna just polywire this. We're gonna add some randomness to that. So that's what we're gonna use in the attribute swap here. So let's just do a turbulent noise. Let's plug in the position. Let's just bind export this, and let's type p-scale, or you could type width, whatever you want, and let's promote these parameters. Probably want to use the time in the offset again. Now I'm thinking about it, so let's do the offset. Let's do a multiply in there. Right, so something like that. Call this speed. And let's do roughness, and let's do a so this will now generate a p-scale. So if I were to type p-scale in here, it will be very big. So that's not what we want. So we want a multiplier in between. Let's do a multiply in between here. Let's promote that parameter. I guess multi, right? So now we can sort of control the overall thickness. And we also don't want those areas where it's like non-existently thin. So let's do a fit range. So the noise, alligator noise will be from 0 to 1. So that's already, so let's do from 0.2 to 2. Oh, what did I do? So let's just do directly switch side. So 0.2 to 2. So let's just, then it won't at least be like infinitely thin. So we can just decrease the, so now you can see it will never be like super thin. And let's increase the frequency. Let's do a little bit of speed, so it will also sort of move through it. And overall thickness should be like pretty thin, something like this. So this looks pretty cool. So let's just assign some color or something. Let's really crank this up so it will actually, and let's add some normals because this doesn't seem to, so it still had the normal stuff there. So this seems to be looking pretty cool. So we could go out here. Let's turn off these boxes that we had. So we could flipbook this. Maybe let's make this red so it's just a little bit easier to see. And let's do some kind of a flipbook to see what we've made. So let's do flipbook. And again, feel free to sort of just like keyframe all these values of like, because like right now sometimes the arcs just stay a little bit long. So I had some of my scatter points like keyed in. But essentially this is sort of how you can do electricity. Like you could add additional layers, like you could have some extra stuff just like generated maybe on the extra pieces that are sort of arcing over it. I didn't do that because like the ones that are here that are like actually from the original one are sort of still connecting here, so they already form these sort of nice arcs. I thought it looked already pretty cool. Yeah, this is just the electricity part. So with that out of the way, let's just move ahead.